I'm Geoff Purdy. I'm a DevOps engineer by day and a Triangle Clojure users group organizer by night. I often tweet from @Clojure as well on relevant topics. Functional programming. Functional programming is a way of thinking and approaching problems as well as structuring programs. How can those of us who don't use functional programming in our day jobs incorporate functional programming into our continuous learning and experimentation? This is not a talk about functions as a service. AWS Lambda, Azure Functions is cool stuff. It's very relevant, but it's not the topic of today's talk. Today is also not about, or at least this talk's not about non-dysfunctional DevOps or avoiding or fixing dysfunction in DevOps teams. Josh Atwood already covered that far better than I ever could. This talk is about functional programming in the DevOps toolchain. The examples tend to come from the right side of the diagram, since that's the world I live in most of the time. I found it amusing that the Wikipedia entry for DevOps toolchain is flagged for excessive buzzwords. So we can talk today about how some of those buzzwords derive from the vocabulary of functional programming. Generally speaking, in functional programming, functions may be passed to other functions, recursion is used heavily, and functions don't modify things outside of their local environment. Must have gotten ahead of the slides. Immutable state, immutability. Don't add, remove, or modify. Instead, create a new one, be that an object, symbol, variable, whatever. It's easier to reason about programs by eliminating shared state, and it also makes things easier to test. Declarative syntax. The programmer defines what should be done without explicitly defining the steps of how to do it. An example that you all are probably familiar with is SQL. Terraform and Puppet are also widely known for their declarative syntax. Programming language theory. This is the point where we can talk about von Neumann architectures, lambda calculus, Turing machines. But I gave this pitch to a DevOps group, and they told me that this is DevOps, we want to learn by doing, show us how to build stuff. So we won't go down that road exactly. You may have heard of Riemann. It's a popular monitoring tool which aggregates events from distributed systems. It can be paired with Graphite and Grafana to build dashboards. Riemann is written in Clojure, and its config files are, in fact, Clojure programs. That is a property of Clojure in some lists, which is code is data, data is code. It's also known as homoiconicity. Next up, NixOS is a research project turned Linux distribution. It's based on the Nix package manager and uses Nix expressions, which is a small functional language. It can do updates and rollbacks atomically. NixOps is a toolchain on top of NixOS, which can be used for build, configuration management, and provisioning of NixOS VMs. You'll note that the code block on the side looked familiar lately. Next up is DSL template generation. In Clojure, a lot of companies are using Clojure and Lisps to generate JSON and YAML templates to be consumed by IAC tools. It takes away some of the pain of writing YAML or JSON. Another cool tool I ran across is Ludwig within Fugue. It is a small functional programming language which has built-in rule enforcement. It's stricter than JSON or a YAML linter, and it results in shorter feedback loops for cloud deployments. You'll notice that many of these preceding examples are not terribly different from what you may be familiar with in imperative programming languages. It's because a lot of imperative languages have adopted functional features later on. Many other languages are multi-paradigm. They actually descend from functional programming languages partially. Learning resources, some links you can follow here. The last one, the MIT SICP course, is excellent, and it's free, and I highly recommend checking it out if you have time. And as a bonus, ClojureConf will be in Durham this year if you want to come and find out about Clojure. The references here, the Backus paper, Can Programming Be Liberated from the von Neumann Style, is excellent and well worth reading. It's not explicitly referenced in the talk, but themes from it run throughout. Thank you very much, everyone.